Hello and welcome to this course on computer vision in Python. My name is Jones Granatier and I will teach all the lectures in this course. Basically, computer vision is a sub-area of artificial intelligence focused on creating systems that can process, analyze, and identify visual data in a similar way to the human eye. The most requested professional in this area is the computer vision engineer, and in this course you will learn everything you need to know in order to get in this world. What makes this course unique is that you will learn the step-by-step implementation of 14 computer vision techniques, or in other words, you will implement the main applications. The good point is that if you have never heard about computer vision, at the end of this course you will have a practical overview of all areas. The course is divided into 14 parts and I will briefly show you the contents and also some applications that you will implement step by step. Let's start with one of the most basic subjects, which is face detection, and in the next sections here we will increase the complexity and we will also implement more interesting projects. Most of the code will be implemented using the Google Colab, so you just need an internet connection and a browser in order to follow the course. See here one example that we are going to implement, detecting the faces of the people in this image. We will also be able to detect eyes, as you can see here, and we will also detect faces on the webcam, as you can see here. When I move my face to the left, to the right, the algorithm can detect my face. On part number 2, you are going to learn face recognition. Here you have some examples. For example, the prediction is class or person number 4, and the expected output, the real face, is also number 4. So the algorithm is making a good prediction. See here some other images that our algorithm will be able to predict. We will also implement face recognition in the webcam. As you can see here, the algorithm is showing my name. In part number 3, you are going to learn how to track objects. So we can select the runner, for example, or any other object, press enter, and see that the algorithm is able to track the runner until the end of the race. In section number 4, you are going to learn about artificial neural networks, and today most commercial applications are developed using this technique, so it is very important that you know the whole theory on this subject, so you will be able to understand the next sections and will also be able to create more complex projects. For this reason, before implementing image classification, you will have many theoretical classes on the fundamentals of neural networks. After, you are going to learn the theory about convolutional neural networks, which are structures widely used in computer vision. Most commercial applications are developed using them. In part 6, you are going to learn about transfer learning and fine-tuning, which is a way to use existing neural networks applied in your own projects. The case study in part 4, 5, and 6 will be the classification of the images, and the goal will be to classify the characters Homer and Bart. We will use several images of the two characters in order to teach the neural network, and at the end, we will send a new image to the algorithm and it will tell us if it is an image of Homer or Bart. The good point is that we will tackle the same problem and test and compare the results of these three techniques. Just in case you don't know the characters, this is a picture of Bart and this is a picture of Homer. And here at the end, the goal is to classify this Homer image. We have a lot of codes that we are going to implement step by step. And at the end, we have the final results, which is Homer, the prediction of the neural network. In part number 7, we will use the knowledge learned in the previous sections to classify emotions in images and videos. We have here the original image with no classification of emotion. We will send this image to our neural network and we will get these results. For example, neutral, happy, surprise, and so on. In part number 8, you will learn another architecture of neural network, which are called autoencoders, and we will use them in a case study for image compression. You can see in the first row of this image, the original ones, then we compress the image, we reduce the size of each one of them, and based on this compressed image, we can reconstruct the image again. In part number 9, you are going to learn how to use YOLO, which is one of the most powerful architectures to detect objects. You can take a look at this video. The algorithm can detect cars, traffic lights, person. Either if the person is holding a handbag, it can detect. So we are going to implement the YOLO technique applied to images and also to videos. In section number 10, you are going to implement gestures or actions detectors. You can see this video here. We will detect all these body points, and when the movement is complete, when arms are up and the legs are apart, we can type a message here indicating this physical exercise is complete. So for example, imagine that you are a personal trainer and you want to monitor if your students are doing the physical exercises correctly. So you can recognize gestures and actions. In part number 11, you are going to learn how to change existing images in order to generate some strange or scary images. For example, this is the original image that we are going to send to our algorithm. And at the end, we have these results. We can see this other image here. And after running for some time, we have this image. Maybe some animals' heads here in the clouds. In section 12, you will implement one of the most interesting projects, and the goal is to transfer the style of one image to other totally different image. You can see here one example that we are going to implement. We have the content image, the image that we want to change, and here we have the style image. See that the new image that was generated has the style of this image. So we can transfer the style of a famous painter to a totally different image and have great results. Here we have another example considering this other style image. So we take the style of this author and we send it to the original image. In part number 13, you will be presented to another interesting type of neural network, which is GANs, and the goal is to train a neural network to generate images similar to the real world. These images here actually don't exist in the real world, and they were generated by a neural network. Finally, in the last section, we are going to use complex convolutional neural network architectures to segment images. See here that first we detect the objects and then we can extract the shape of them. You can see it here. that we are extracting only the information about this specific dog. This is image segmentation. We will also apply image segmentation to videos. See here that we can detect cars, traffic lights, person riding a motorcycle, and so on. This course is suitable for beginners in computer vision since it covers from the basics to more advanced algorithms, and also for professionals who would like to review the main areas of computer vision. It is important that you have basic knowledge of the Python programming language, as we will not cover the basics of the language in the course. Another important detail is that you will learn only the most basic theory about the algorithms, except neural networks that we will have a lot of theoretical classes. So, don't expect too much from the theory because the main goal of the course is to present an overview of the area and focus on practical implementations with Python. It is important to emphasize that we could create a complete course with many hours on each one of these topics, and in this course you will have a summary of all areas of computer vision. Finally, we will use several libraries such as OpenCV, dlib, TensorFlow, darknet, and also the Caffe framework. And another good point of the course is that you will have a lot of homeworks at the end of each one of the sections, as well as videos with the solutions. We hope you have a great course and enjoy the content. See you in the next lecture.